Example of the last section of chapter 2. This will take care of distance, midpoint, and the equation of a circle all in one question. Alright, so here we have two coordinates on a piece of graph paper. And usually when I'm dealing with coordinates, I just like to know their location. So negative 3, 4 would be negative 3 this way and 4 up. And 9, negative 6 would be 9 to the right and 6 down. So we have these two endpoints. And this line segment that connects them, this is the diameter of a circle. So you can imagine that there's this circle going around those two coordinates where that happens to be the diameter. Well, if we're looking for the equation of a circle, we need to find the center. We also need to find the distance the center is away from any point on the circle, also known as the radius, which happens to be, by the way, half a diameter. Alright. So the first thing I need to do is define the center. Well, to find the center, that's directly in the middle of these two endpoints, which would be the midpoint. So the first thing up is, let's find the midpoint of these two coordinates. And to find the midpoint, it's literally just the average of the x's and the average of the y's. Add the two numbers together, divide by 2. So if we average the x's, it would be negative 3 plus 9, and we'll divide that by 2. And then average the y's, that'll be 4 plus a negative 6, and then we'll divide that also by 2. So the midpoint here is going to be 6 divided by 2, which is 3. Over here it'll just be negative 2 divided by 2 is negative 1. So the midpoint, the center of the circle, must have coordinates of 3, negative 1. The other thing that's important for the equation of a circle is distance. So I need to find the distance between some points. And you have a couple choices. You could find the distance between the two original points, and to find the radius you just cut it in half. Or you can start at the center and just go to one of those 2 points. I'm going to stick with the center to the point on the circle, the strict definition of what a radius is. So we need to find the distance between these 2 points. And the formula I like using for distance is the change in x squared plus the change in y squared added together, square rooted. Alright, so all I need to do is find change of x and change in y. So the change in x, kind of like slope, but be careful, we don't want to combine the answers. The change in x would be negative 3 minus 9. I'm going to the center. Negative 3 minus 3. So it would be negative 3 minus 3, which would give me negative 6. And the change in y's would be 4 minus a negative 1, better known as 4 plus 1, better known as 5. Alright, so if we plug this into the formula, we're going to get the change in x squared, which would be negative 6 all squared. Make sure it goes in parentheses because it's a negative. Plus the change in y squared, which would just be 5 squared. So this becomes the square root of 36 plus 25, better known as the square root of 61. Alright, so we have the center, which is 3, 1, over here, 3, negative 1, and we have the distance of the radius, or the length of the radius, square root of 61. So the next step would be to plug it into the equation of a circle, which is x minus h all squared plus y minus k all squared is equal to the radius squared. H in this case is 3, k is negative 1, and r is the square root of 61. So when I get done with this, it'll be x minus 3 all squared plus y plus 1 squared is equal to, well, if I square the square root of 61, that just gives me 61. And there's our equation of a circle, who goes through these 2 points where its diameters are these endpoints, and that's it.